Hello everyone, hope you all are doing well. In this video, we'll discuss the second problem of Leetcode BiWeekly contest 80. It's a medium level problem, the second problem of this contest. So the name of the problem is successful pairs of spells and quotients. So the problem statement says that we are given two integer arrays, spells and quotients of length n and n respectively, where spells of I represent the strength of ith spell, and similarly quotient of j represent the strength of jth quotient. So we are also given an integer success. So a spell and quotient pair is considered successful if the product of their strength is at least success. So return an integer array pairs of length n, where pairs of I is the number of quotients that will form a successful pair with the ith spell. So in short, we have two arrays, and all we need to do is that we pick up the first array, and it tells what is a successful pair. So a successful pair is that when product of two numbers is at least equal to a given value. Here it is known as success. So we need to pick the first array. Here in this case we need to pick spells. We pick up each and every index, and we check that for that particular index how many values in quotients make a successful pair with that particular value, and we need to return the count for each and every index for that. So if we look into the example, then we see that these are the values in spells, these are the values in quotients, and the success value is 7. So let's see if we talk about 5, the first value, right? So we see that how many values in quotients make a successful pair with 5. We see here that if we multiply this array with 5, so each and every value, so the first one is 5 because 5 into 1 is 5, so it is less than 7, so it's not a successful pair. Then we make 5 into 2, it comes out to be 10, so it is greater than 7, so it is a successful pair. Similar for the remaining values. 5 is able to make a successful pair, so for 5 we have 4 values in quotients. Now if we talk about 1, then if we multiply 1 with any of the values, the value will always be less than 7, so we return 0, that no pair for this 1 can be made. And similarly, if we pick up value 3, then we see that the 3 pairs can be made. They are 3, 4 and 5, because when we multiply 3 with 3 it comes 9, greater than 7. Similarly, when we multiply 4 with 3 it comes out to be 12, which is again greater than 7, and so on. So we return 403. Similarly for the second case, so if we look into the constraints, and then n and m are the length of the two arrays, and uh, again it goes up to 10 raised to the power 5, and value of each number can go up to 10 raised to the power 5, and success is 10 raised to the power 10. So that means we need to deal with long values. It's an helpful thing that we can see here, that whenever we try to compare it, or the product can go beyond an integer range, because if we multiply two numbers of range 10 raised to the power 5, then obviously that can overflow. So now let's look how we can approach this problem. So if we come to the whiteboard, then so this is the this is the array. If I select it, this is the array, and we have some values in it. We have some values. Let's call it, so here it is called, let's call it array 1, right? Let's call it array 1, and then we have array 2. These are the two arrays. So now for each value of array 1, we need to tell that how many values in array 2 are there, such that when we multiply this particular value with this value, it makes up a successful pair. So we need to count the number of elements in array 2. And the definition of a successful number is given that you multiply this ith number with jth number. If the value comes out to be greater than success, then that is a successful pair. So now what we can do is that, so we need to compute the value, we need to compute the number of pairs for each value present in array 1. So that means if we sort the second array, suppose we sort the second array, we have a sorted array, right? If we sort the second array, and if we are at position k, suppose this is position k, right? So if we pick the first value of array 1 and we multiply it with the kth value of the sorted array of the second array, and if it is a successful pair, then that means all the values present beyond this index also will be making a successful pair with the ith index, right? Because suppose you multiply 2, suppose this is value 2 and suppose this is value 3. So 2 cross 3 is equals to 6. Now the values present here on the right side of this kth index are either equal to 3 or greater than 3, right? So that means if you multiply any of these values with 2, we will be receiving a value greater than this value. So if this is successful, then all these are successful, right? So the trick here is that for each and every index, I, we we do a binary search in the sorted array. The second array is a sorted array, and check that which is the first index in the sorted array, that is making a successful pair, and then we return the number of elements on the right side of this, means including the kth element. So this will be, this will be a solution. If we look into how to code it, then let's come to the code. So here we can see we have sorted the second array, and again we have initialized an answer array. So now we start traversing the array. So we traverse the first array of length n because we need to compute the number of pairs for each and every element of first array, right? And the length of the array is n. And this is the binary search logic. So what we do, we take a low, we take a high. These are the indices of the second array, of the sorted array that we want to traverse, and this is an answer index. That means this is the first index in the sorted array which is making a pair with the ith index of the first array, right? So we do a binary search. While low is less than high, we compute the midpoint, we calculate the product. The product will be, so we are at the midpoint, so the value at this position in the second array and the current element that we are considering for the first array. We see what is the product. Now if the product is greater than success, then our answer will be this, and there is a possibility that there is an index which is valid on the left side as well. So we move our range to left side. That means high becomes mid minus 1. However, if this condition is not met, that means we need to search on the right hand part. So then we make low is equal to mid plus 1. Finally, after this binary search loop is done, we check that if our index is not equal to minus 1, that means we were able to find an index which was making a valid pair. So all we do is that we calculate how many elements do we have. So it comes out to be m minus answer index, because suppose total we have 5 elements, and if the second index is making a valid pair, so how many indices will be making a valid pair? It will be 2, 3 and 4. But how many elements do we have? It is 3. 5 minus 2. So that is why we are making m minus answer index. So finally we do this for all the elements in the first array, and then we return the answer. If we talk about the time complexity for this one, then sorting the second array, that will take m log m, because the size of the array is m, and this is a binary search. So for each and every element, so for n elements, we are doing binary search on m elements. So this will be something like, for sorting, it is big O of just a second, it's big O of m log m plus, for n elements we are doing this. So this is the time complexity. And yeah, hope you learned something new from this video, and see you in the next video. Do support this video by giving up a thumbs up, and yeah, take care. Bye bye.